Welcome to qnawire.
Okay, we have that the normal boiling point of liquid ethanol is 351 Kelvin. And if we assume that the molar heat of vaporization is 45.1 kilojoules per mole, the question is when the external pressure equals 0.602 atmosphere, what is the boiling point? For this, we need to use the Clausius-Clapeyron equation. So the Clausius-Clapeyron equation tells us that the ratio of the log of the pressure uh, at some different temperature or different pressure, like P2, this is our adjusted pressure, over the normal boiling point pressure, so that would be P1 equals 1 atmosphere, is equal to the negative of the delta H vaporization over the gas constant R times 1 over the adjusted temperature, T2, minus 1 over the normal boiling point, T1. So if we plug in the values that we know into this, we're going to get the natural log of 0.602 atmospheres over 1 atmosphere is equal to negative 451 or 445.1 kilojoules per mole over 8.314. Let's see, this is going to be in joules, so to put it in kilojoules, we're going to want to multiply by 10 to the negative 3. So 8.314 times 10 to the negative 3 joules. Now this is kilojoules per mole, Kelvin. And then our temperatures go in here. We do 1 over, this is the temperature we're trying to find, 1 over T2, and then T1 is just the normal boiling point, which we know to be 351 Kelvin. Okay, at this point, we've just got to solve for T2. So essentially, we're going to have this ln, and the 1 and the atmospheres will cancel. So this is just a natural log of 0.602. And then we're going to multiply over R and divide by the negative of delta H vaporization. So we'll get this 8.314 times 10 to the minus third. The units are going to cancel except for Kelvin over 45.1, and I put the negative out in front of the log if you're wondering where that went, is going to be equal to 1 over T2 minus 1 over 351 Kelvin. And we've got units of Kelvin left over here. Okay, and now we just need to move over the 1 over 351 Kelvin. So we're going to end up with 1 over 351 Kelvin minus the natural log of 0.602 times 8.314 times 10 to the negative third Kelvin over 451 equals 1 over, let's see, 1 over T2. And then if we just put this to the negative 1, then this will be equal to T2. Okay, so let's just start plugging this into a calculator. So we've got 1 over 351 minus the natural log of 0.602 times 8.314 e negative 3 divided by 45.1. And that entire thing, we want 1 over that. And I get 346.1 Kelvin. So to round to sig figs, it'll just be 346 Kelvin. So that's just using the Clausius-Clapeyron equation.